So today I'm here in the manufacturing lab. We're going to be working with Helical Solutions and Harvey Performance. They've actually sent me a bunch of end mills, and today we're going to be talking about continuous time and cut. Now that's where that end mill is actually engaged in material, and the length of time that it's engaged can really affect tool performance and wear. So let's take a look at these tools. This is actually a 6-flute tool. We've got some big blocks of 17.4 stainless in here. Let's get this chucked up and give it a try.
Jesse.
Hey, Don.
How you doing, man?
Welcome back. I know you were telling me about a customer, your testing showed you can only do 200-300, and then you go to a customer and they're running 500-600, and you looked at their program, and this is really where you made that realization.
Absolutely, and this is where it gets confusing, right? Because everybody's running surface foot in different areas at different amounts. So what's going on there, right? It's called continuous time and cut, which basically has the principle that when an end mill is in cut for too long, the friction builds up too high and your surface foot can be sacrificed. And I really think this continuous time and cut that we proved in theory and in science, now we're going to show some experience and hopefully prove that at your machine.
So I know we kind of want to see the limits of these tools, so I set it up with the elevated surface foot parameters that you gave me. We're in stainless steel here. We've got that single circular pocket. So we're going to keep that tool engaged the whole time and see if we can burn something up.
Can't wait, let's do it.
Let's give it a try. Man, I did not think that tool was going to make it the whole way.
Didn't sound good there at the end.
Well, we got a little build up there.
We do, absolutely. See, now our CTIC was high on this one, right? Continuous time and cut. We had it jacked up. We had surface foot up. When you get that heat, you get that friction, and that tool's in cut, that's what you get.
Yeah,
we get built up edge.
So what I'm thinking is we shift the start point of the tool path, move that helix over to the far edge of this circular pocket. That'll allow that tool to come out of material, do a micro lift. Really easy to adjust in Mastercam, not a big deal. Why don't we get a new tool loaded up, a new blank in, and try that out.
Let's do it.
Well, that sounded a lot better.
It did. I think we're gonna have good results on this one.
And the holder is noticeably cooler.
It is.
Tool looks better to me, to my untrained eye. I'd like to hear your opinion on it.
Now that looks a lot better.
Yeah.
The reduced CTIC definitely made a difference.
It sounded better.
It did.
Sounded better. It sounded like we could cut 3 or 4 more of these with those cutting parameters.
Oh, with this tool, probably more than that. Just
so, I mean, I think that kind of proves the point, but not every part is a circular pocket.
True.
In a block, right?
True.
So there's a lot of cases that are going to be completely different, and in many cases, you are going to have a reduced CTIC just because of the part. All right, so this is what we're going to try and do. We're going to take that square block into a boss, continuously in cut all the way around, and ideally we'll get some failure. Now, I know you said we were going to fail at 650 SFM. Yeah. We didn't. So we're going to go higher?
We're going to bring it up to 800.
Okay.
I think 800.
Right.
Hopefully we see the failure. We think they are helical tools, so they do last a while, Jesse. Yeah. But let's go up to 800.
Let's get it loaded up and see what we get.
Sounds good.
Well, that one sounded good. Whoa, man, that is warm. Careful on that one.
Man.
We saw the heat in the infrared camera.
Now that one got so hot it changed colors.
Yeah.
And to get carbide and that coating that hot, that you have that purple color in there, that means that we really warmed this thing up.
We were making some heat, yeah. Well, you said it was going to break at 800. We just made it hot.
That's right. So. We made it hot, but I'll tell you what, it's not going to last much longer with that high of a CTIC.
Yeah. Now we got to kind of think about programming strategies here, right? How are we going to reduce CTIC on a part like this? It's not easy.
Yeah.
Right? Maybe something like a peel mill where we take a channel here, and then use 2D dynamic to go on each side of that boss.
I think the plan, and you're spot on, the plan is to reduce that CTIC continuous time and cut. And if you have to do it with a trochoidal path, I know your software can do it. Let's program it and give it a try.
So for this one, like we talked about, right, I've got the peel mill running down one side, a peel mill coming down the other side, and then we're doing that 2D dynamics to clear out there. I do have some concerns with this, right? We're reducing CTIC, but now we're going to be at the end of these where it breaks through. We're going to be pushing over these walls. And 17.4, it's a tougher material. It might damage those tools.
Yeah, you're spot on. You have a lot more flags, a lot more issues, entering, exiting. CTIC is lower. That's what we're trying to prove out.
I think we're going to reduce temperature. I just think we might have some other issues.
One way to find out, Jesse.
There is. Let's give it a shot.
Let's do it.
So that sounded good almost the whole way through, but at the end there, it was not happy.
Yeah, it wasn't. I'll tell you what, we might have introduced a couple more
you can
problems.
look at the ugly burrs on that part.
Ouch.
The tool is cooler, the holder's cooler.
Okay.
But, oh yeah, check that out.
Ooh. Okay, now what I can tell from this is it looks like we beat it up pretty good. But I can tell you, the heat was gone.
You don't have that purple color down on the tip anymore.
It's almost like we solved one problem and we got the heat out, but we introduced another problem.
I'm kind of thinking that peel mill, it was actually harder to program, right? Doing this idea with the diagonal cut across the center, that's going to be even easier.
Yeah, I think so, and it's going to eliminate a lot of problems.
Let me program that up.
Yeah, Jesse, this is part of the process, right? In order to eliminate some of the problems, you have to change the tool path, change tools, and go from there.
And we are still at that same 800 surface feet, same step over. Everything is exactly the same, and we're removing the same cubes of material.
Sure.
So let's see what it does to the tool.
Give it a try.
Well, we certainly didn't get that grumbling at the end of the cut on this one.
Sounded a lot better, Jesse.
And this tool's just warm now.
Yeah.
You take the part out here.
Let's take a look at it.
Surface finish on the part looks good. We're not getting those burrs that we got last time here.
Now that looks a lot better.
Yeah.
A lot better.
Yeah, you don't have any buildup, no chipping on the edge,
This
no
tool
discoloration.
hardly looks used.
Yeah, looks good. It's mind-blowing the difference here, right? Same exact cutting parameters, same exact amount of material removed, same machine, same holder, same everything, and yet we're seeing these huge differences in the tool.
CTIC.
Yeah.
Continuous time and cut. I'm telling you,
Yeah.
have to be mindful about it.
Yeah, you're onto something there.
It was fun. I'll tell you what, we had a lot of fun because you can talk in theory, you can use the science, proving it out at the spindle using your software, Mastercam, and actually running through this process, I think gives us some pretty concrete results.
Yeah, and it's great to have that flexibility when programming, to be able to make these changes on the fly and see real world results.
We're trying to get the heat up there to show the difference and the results you get with a high continuous time and cut and a low continuous time and cut.
And I mean, it's there.
It's there.
We're seeing it. And I think it's not the end all be all, right? It's not like break up all your tool paths to reduce that time and cut, because there's other considerations. Sometimes you don't care about tool life or you don't care about cycle time.
Absolutely.
This is just something that, it's knowledge. It's something to be aware of, something that lets you make more informed decisions while you're sitting in front of Mastercam programming.
100%. Education is the key.
Yeah.
It's smart for our cutting tools, it's smart for the actual programming side, and at the end of the day, we both win.
Well, Don, you were right about one thing, and that was CTIC. But you were wrong about something, and that was that we were going to break tools today.
We still got time.
Not today, not today.
Appreciate it.
Yeah,
Thank you.
Thank you, Don.
Take care.